Hello, science family. Hey, we are going to talk about the periodic table and just take a little tour of the whole map and what it is and what it's all about. So let's do a little bit of history before we get into the nitty-gritty. Carry on. We want to give much love and respect to Dmitry Mendeleev. This gent right here, this amazing young Russian man who had a wicked beard, actually was one of the founding fathers of the periodic table. The reason he gets credit and what's amazing is that he started putting elements in order by atomic mass. Now, we didn't really know about protons yet, and we did not know about atomic number, so he started putting them in order by atomic mass, but he also put them in columns with similar chemical properties. So he said, these guys react with the same stuff. So let's put them in the same column, even though they have different masses. Putting them by order of mass, and he had such faith in the chart that he actually left a few spots blank, but said, I don't know what these elements are, but I think we still have to discover them. And when we do, I bet they'll react like this, have a mass around this. And crazy enough, this guy was right. So Mendeleev, thank you for everything you did for being our grandfather of the periodic table. Let's give him a smiley face on his head. All right, let's move on and get a little upgrade in history. Now, once we figured out about protons, enter Moseley. Moseley took Mendeleev's periodic table, but upgraded it just slightly. He put everything in order by proton number. If you look on the periodic table, still most of the elements are in order by average atomic mass, but a few are slightly out of order by mass, and we put them in order by proton number. But by doing so, we got the modern day periodic table and what it is today. And by the way, when we actually found out those missing elements that Dmitry Mendeleev predicted, he was pretty darn close and right. So that's amazing. Now let's talk about the parts of the periodic table. If you look on your periodic table, the horizontal rows, all right? So going from left to right, the horizontal rows, those are called periods. And there happens to be 7 of them. 1, 2, 3, 4, 5, 6, 7. You might be saying, hey, what about these guys down here? Well, technically, they're injected right into rows 6 and 7. We just pull them out to save room. I'll talk about that a little bit later. But there are 7 periods. You'll also know later on that there happen to be 7 energy levels, too, with electrons. But let's not go too fast. Now, groups and families happen to be the vertical columns. We actually talked about groups and families already slightly. Why or when? We talked about them because when you label them 1, 2, 3, 4, 5, 6, 7, 8, that actually tells you the trend for valence electrons. So we've already kind of talked about the vertical columns of the groups. But we can't forget about these guys either. They also have a group or family, and they're going to have some special names too. But don't forget, because they're in a group or family, that means they have similar properties. So they're going to have similar chemical properties and maybe even physical properties. So we'll get into that also. Take a look at a periodic table up close. Take a look. Each group or family is numbered. We go all the way up to 18. All right? And don't forget about our horizontal rows or our periods. They go all the way up to 7. Again, these guys are injected in 7 and 6 for the rows. Now, if we're going to name each group or family, let's start by designating the group and then the name. So group number 1 over here are called the alkali metals. So all of the elements that are found in that very first group, okay, are called alkali metals. Any in group number 2 or family 2 are called the alkaline earth metals, right? And this is good to memorize. Even though we're not huge on memorizing, you should know the family names because sometimes we'll reference them, saying, all alkaline earth metals react this way with hydrochloric acid. And that way you'll know, all the column 2 family members do that, right? There is a big group that is groups 3 through 12, and those groups 3 through 12 are called the transition metals. They're all metals. They all fall into the same family, but they all have a lot of different properties and traits. It's a little messy around there. So we bunch them all together as the transition metals, okay? Things like gold are in there, things like platinum, silver, iron, zinc, copper, nickel. All right, so a lot of the metals we know in everyday life are stuck in those transition metals. But those are the family names I need you to know for the metals. Now for the nonmetals, we'll focus on two main groups. Group 17 is right here, which is the halogens. By the way, if they're group 17, that means they have 7 valence electrons, which means they all like to form a -1 anion, and that eventually is going to lead to why they all have similar chemical reactivities, because of that -1 charge. So the reason that family members in the same group, the same vertical column, act similarly often is because of their valence electrons and what charge they can make. The very last group that we may have discussed already, group 18, sometimes we call that group 0 too, but 18 mostly, that is the noble gases. Those guys have 8 valence electrons. They're super happy and they stand above everybody else, kind of like a king and a queen. Here's my crown, here's my head, here's my face. Noble gases are happy with 8 valence electrons, so they don't like to react too much, so they all have similar chemical reactivities because they're in the same family. And that happens to be that they aren't very reactive at all. All right, so for nonmetals, know your halogen group and noble gas group. There are other family names like the boron, carbon, and nitrogen and oxygen family, just named after the element that's at the top, but these are really the two big ones to know. To kind of sum everything up of what we just talked about, here they are. The two family names we didn't name are the lanthanides and actinides. Those will become way more important when we do nuclear chemistry in a few weeks. But for now, they're not super important, but we will have them come up in class a little later on. All right? Don't forget noble gases, halogens, alkaline earth, alkali metals, and the transition elements. By the way, the reason that we pull out the actinides and lanthanides are because it just makes the periodic table a little bit more condensed. If you put these guys back into the periodic table would stretch out like this. Yo! So there's the lanthanides and actinides put in there, and now the periodic table is a heck of a lot wider. That's why we just take them and push them off to the bottom and bring these green pieces together, all right? They're all part of the same family. Everybody's stuck together, and because of that, it makes the periodic table a little bit more condensed. But anyways, this is the initial journey and tour into the periodic table. We're gonna go a lot deeper, but this is a good place to start. Thanks for listening, and best of luck, Science fam.